Good day, students. Welcome to math.server.com. In this clip, we're going to be going over the second part of our limit interactive multiple choice solutions. So let's go ahead and take a look at problem number 5. We have to find the limit as x approaches -1 from the right of this expression. We're going to go ahead and attempt to find this limit by direct substitution, okay? So let's go ahead and plug in the value. So we're going to have e to the 1 over -1 from the right plus 1 divided by e to the 1 over -1 from the right plus 1 plus 1. Okay, this becomes e to the 1 over 0 from the right divided by e to the 1 over 0 from the right plus 1. If you simplify this further, you have e to the infinity divided by e to the infinity plus 1. So we have infinity over infinity plus 1, which is infinity over infinity. This is an indeterminate form, okay? So direct substitution doesn't work. So the other method we can use here is something known as the L'Hopital's rule, okay? So L'Hopital's rule just involves finding the derivative of this expression and then taking the limit, okay? We just take the derivative of the numerator and the denominator. So for L'Hopital's rule, the limit as x approaches -1 from the right of this expression, e to the 1 over x plus 1 divided by e to the 1 over x plus 1 plus 1 is basically the same thing as the limit as x approaches -1 from the right of the derivative, okay, of d dx of the numerator e to the 1 over x plus 1 over the derivative of the denominator. Okay, so d dx of e to the 1 over x plus 1 plus 1. Okay, all right, so let's go ahead and find the derivative. So we're going to have the limit as x approaches -1 from the right. If you differentiate this, we're going to use the chain rule. We're going to have e to the 1 over x plus 1 times, now if you want to find the derivative of 1 over x plus 1, this is how you do it. So 1 over x plus 1 is the same thing as x plus 1 to the -1. Alright, so if you want to find the derivative of this, you're going to have -x plus 1 raised to the second power. Alright, so using the chain rule, the outer function is e to the x. If you differentiate that, you end up with e to the x times the derivative of the inner function is going to be -x plus 1 raised to the -2 times 1. Alright, so the derivative here is going to be e to the x evaluated at the inner function, which is 1 over x plus 1 times the derivative of 1 over x plus 1. As we can see here, the derivative of 1 over x plus 1 is -x plus 1 to the second power. Okay, so we're going to put it down here, -x plus 1 to the -2 power divided by, same thing here, we're going to have e to the 1 over x plus 1 times -x plus 1 to the -2, and then the derivative of 1 is just 0. Okay, all right, so what do you notice here? Well, what you notice is after differentiating, the 0 drops off and we have identical expressions. Okay, so just ignore that. So what happens here is if you differentiate, you find out that the numerator and the denominator are identical. So what do? You can just divide them out. This divides with that divides with that, and your answer is just 1. So you're going to have the limit as x approaches -1 from the right of 1 over 1, which is just 1. So we can see that the answer is D. So you just have to remember that anytime you have an indeterminate form, infinity over infinity, you can use L'Hopital's rule as a shortcut. Just find the derivative of the top and the bottom, take the limit again, and then whatever answer you get, that should be your limit. All right, let's take a look at question number 6. So we're going to evaluate this limit by direct substitution first. If we have an indeterminate form, then we can use L'Hopital's rule, okay? So let's go ahead and evaluate this limit. So we're going to do a direct substitution. We'll have e to the 1 over negative 3 from the left plus 3 divided by e to the 1 over negative 3 from the left plus 3 plus 1 plus 2. Okay? So if we simplify this further, we'll have negative e to the, let's see, this is going to be 0 from the left, so 1 over 0 from the left, over, the same thing here, e to the 1 over 0 from the left, plus 1, plus 2. Okay? And then when you simplify that, you're going to have negative e 1 over an infinitely large negative number, really close to 0 from the left. If you divide it out, you end up with an infinitely large negative number. Okay? Divided by the same story here, e to the negative infinity, plus 1, plus 2. So simplify further, using the reciprocal property of exponents. Because of this negative exponent here, you have 1 over e to the infinity, and then here also you have 1 over e to the infinity plus 1 plus 2. Okay? Simplifying further, you have negative 1 over e to the infinity is the same thing as 1 over infinity, divided by, same story here, 1 over infinity plus 1 plus 2. Alright, so simplifying further, we have negative 1 over infinity is just 0, so 0, 1 over infinity here is 0 also, plus 1, and your final answer is simply going to be, oh actually this is plus 2, I changed it, sorry. So 2, 2, 2, so 0 plus 2 is just going to be 2. Alright, so our answer is option letter D. Alright, let's take a look at problem 7. This is an absolute value function. So we can write this as the limit as x approaches negative 2 from the right. So absolute value can also be expressed as plus or minus. Put that in front of the 5, x plus 2 divided by x plus 2. Since we're approaching from the right, we're just going to take the positive sign, so this becomes the limit as x approaches negative 2. Now, this directionality of the value approaching means we're just going to have the positive piece, so we just have 5 over x plus 2 divided by x plus 2. Okay? And then what you notice happening here is that these two quantities are identical, they divide out. So you have the limit as x approaches negative 2 from the right of 5. Final answer is 5. Alright, let's take a look at problem number 8. It's very similar to what we just did. So for this one, we're going to write this as a limit as x approaches negative 1 from the left of plus or minus 5 over x plus 1 over x plus 1. Okay. Now since we're approaching from the left, which sign are we going to take? Plus or minus? Since we're approaching from the left, we're going to take minus, so we have minus 5 times x plus 1 over x plus 1. Alright? Now these two quantities are identical, so they divide out. And now we're going to have the limit as x approaches -1 from the left of -5, and your answer is -5. So our answer for number 8 is option letter C. Alright, so for number 9, we have the limit of a complex fraction. One thing you'll notice here is if you plug in -1, you end up with a situation that you're dividing by 0. So direct substitution doesn't work as a first method of approach here. Okay, so direct substitution fails, so we have to simplify this complex fraction. So how do we simplify this complex fraction? Well, by simply multiplying the numerator and the denominator by this denominator right here. Okay, so I'll multiply the denominator by 1 plus x, all right? And then multiply the numerator by the exact same quantity so we do not change the problem. All right, so if I do that, I'm going to end up with, this is going to become the limit as x approaches -1, the numerator of x times 1 plus x divided by, in the denominator, when I distribute, I'll have 1 minus, and then the quantity 1 plus x. Alright? Okay, so now this looks much better. If I simplify this further, this becomes the limit as x approaches -1 of x times 1 plus x divided by, and then these two minuses cancel out, x. And then you divide out this x and the x. This becomes the limit as x approaches -1 of 1 plus x. Plug in -1, you have -1. I'm sorry, you have 1. 1 plus -1, which is equal to 0. So the answer for number 9 is option letter C.